In this video, we're going to learn how to calculate the area of a two-dimensional shape. So what is area? Well, think of an area as the number of 1 by 1 squares that you can fit inside of an object. So here, for example, let's say this square was 1 centimeter by 1 centimeter. Well, it's a square. And it's a square that is measuring 1 centimeter in both directions. So we would call it a square centimeter. Makes sense, I hope. Well, remember that square means something in mathematics. It means to raise something to the power of 2. So this is actually saying a centimeter that is squared means the same thing. And there's one of these square centimeters. So this is literally called 1 square centimeter because it's an actual physical square that is 1 centimeter by 1 centimeter. The question is, how many square centimeters can you fit into a shape like this? I suppose we could count if we wanted to. So 4 centimeters means we can fit squares in here. Well, there's 4, and it's 2 centimeters tall, so we have another 4 up here. So that would be a total of 8 square centimeters, or 8 centimeters squared. But I don't want to have to count squares every single time I do these, especially when they get more complicated. It's better to have mathematics to do this for us. So it turns out that with a rectangle, the way to do these, so this works for rectangles. It's the length times the width, or the width times the height. There's many ways to think about this. It's basically the length of one side times the length of the other side. So for the sake of practice here, let's call this the length, and we'll call this the width. Well, fair enough. That means that we have, in this example, a width of 4 centimeters and a length of 2 centimeters. Well, what's the length times the width? That would be 2 centimeters times 4 centimeters. Now, interestingly enough, and I find most people don't really realize this, 2 times 4 is 8, of course, but a centimeter times a centimeter, anything times by itself would make that thing squared. So this actually does make 8 centimeters squared because it's a centimeter times a centimeter. So if we read this, we read 8 centimeters squared, or 8 squared centimeters. It actually goes back to our definition of a square centimeter, which is an actual square that is 1 centimeter by 1 centimeter. Now, here is a common mistake that I see people making. Please do not make this mistake. Do not, if you see a square here, some people think that they have to now square the 8 to get 64 centimeters squared or something like that. You already did the multiplication of 2 times 4. You do not then have to do 8 times 8. That's been taken care of. 8 centimeters squared is the answer. Please do not put 64 as the answer. Remember that the square centimeter means that the centimeter itself is squared, or it is a square. Anyways, let's try this one. So sometimes in these images, you'll see little tick marks on a line like this. That just means that every side that has this tick on it is the same length as every other one that has that tick. So if this length is 7 on this side, that means that every side is 7 centimeters. Well, what would the area be if it was 7 by 7 by 7 by 7? Well, let's do the length times width again. So it doesn't really matter which is which. It seems as though the length here is 7, and the width is also 7 because every side is 7. So what's 7 times 7? That would be 49. And then a centimeter times a centimeter is a centimeter squared. So we would call this a square because all the sides are the same length. But a square is just basically a rectangle. It's a very specific kind of rectangle where all the sides are the same length. So rectangles, they don't have to be the same length on every side. But you can use the formula of a rectangle for a square because it's a more specific rectangle. Circles. So you're going to notice that a lot of these shapes, they all just have their own formula that you can look up somewhere. So for circles, for example, this is a common one that I recommend people know by heart. The area is equal to pi r squared. Now what's pi? Well, if this is the first time you've ever seen pi, just know that it's 3.14. Now there are more decimal places that exist. There's actually infinite decimal places, but 3.14 is usually good enough. So this means 3.14 times r again, because it's r squared. So I should probably explain myself. What is r? Well, r is known as the radius. R is the radius. And the radius is the distance between the center of a circle and the edge of the circle. So no matter where I measure this, the radius should be the same everywhere. All of these radii is plural for radius, they should all be the same length if it's a circle. So would I put 4 meters for this? Because I see a 4 meters up here. Well, actually, no. We would not put 4 meters for the radius because 4 meters is the diameter, which is the distance from the outside all the way to the other outside as it crosses through the middle. So we have the diameter, which is 4 meters. And the diameter is actually just 2 times the radius. The radius is just half of the diameter. So half of 4, always just take the diameter and divide it by 2. And you'll get 2 meters in this example as the radius. Now let's apply this area equation, or area formula. 3.14 times the radius, which is 2 meters, squared, or times the radius again. So 3.14 times 2 is about 12.56 meters squared, because there's a meter times a meter. This is our area, and this is how many square meters we can fit into this circle. Triangles are the last of the 3 shapes. So every shape that exists can be broken down into circles, rectangles, and triangles. They're the 3 fundamental shapes. 3 fundamental 2D shapes, I would say. So it's important to know one of each, at least how to calculate each of them for their areas. So how do we do triangles? Well, they're very similar to rectangles, and I'll show you why. What if this was a rectangle? What if I made this into a rectangle? Well, how big would this rectangle be? It would be 10 meters wide and 6 meters tall. So the area of the rectangle itself would be the length times the width. which would be 6 meters times 10 meters, which is 60 square meters. But a triangle, if we think, okay, well, only the part that I colored in that's white is the area that I want. The first half of this thing, it's not really half, but the first piece of this rectangle, you'll see that exactly half of it has been colored in white. And if you look at the second piece, the same thing. It turns out triangles are just half of a rectangle. So any triangle that's, I suppose, a right angle, two of them would form a rectangle with the same height and width. So it doesn't matter what the triangle really looks like. As long as you know the height of the triangle and the width of the triangle, the area is just going to be the length times the width, just like the rectangle, but then divided by 2 because it's half. So the area of a triangle, I'll write that in white, area of a triangle is the length times the width divided by 2. In this case, it would be still 10 meters. We'll say 6 meters, which is the length, times 10 meters all over 2. So 60 meters squared over 2, which is 30 meters squared. So it's just half of the area of a rectangle of the same size. Now this one is a crazy example, but I really want to explain a few things. So the goal here is to calculate the area of the shaded region, or the region that's colored in white. And this will be a review of all of the previous 4 questions that I showed above. Now, one thing to understand is you could always take away area by subtracting. So we'll see how that works in a moment. So where to begin with this thing? Let's start by looking at this triangle and this triangle together. Let's ignore this hole for a moment. Let's just say that this was fully colored in. What would the area of this triangle be? I guess I'll color it very lightly in blue. What would the area of this triangle plus this triangle be equal to? Well, if we know the rectangle that it's forming, if we know the area of this rectangle, it would just be half of that area. So, in other words, the area of the triangle would be the length times the width divided by 2. What's the length here? It's the height, same thing, height, length, 4 meters, and then the width is 10 meters, all divided by 2. 4 meters times 10 meters is 40 square meters, divided by 2 is 20 square meters. And then let's think about what's happening on the inside here. There are these circles. So yes, the 2 triangles would form 20 square meters if they were fully colored in, but there's actually a hole in this triangle, and it's a circular hole of diameter 2 meters. So the area of the circle would be pi times r squared, and we said the diameter here was 2 meters. That means the radius is half of that, so it's 1 meter. So pi is 3.14 times 1 meter times 1 meter well, 1 times 1 is just 1 anyways, and then 1 times 3.14 is 3.14, and then you have meters squared. So if I really want to know what the area of those two triangles are, I have to subtract the area of the triangle if there were no holes in it from the area of the circle that is missing from it. So the area of, I'll call it the triangle with the hole in it, is going to be the area of the triangle minus the area of the hole, which is 20 meters squared minus 3.14 meters squared, which is, let's do some math here with a calculator. 20 minus 3.14, 16.86 meters squared. We're not finished yet though, because there is another colored area right here. And well, wouldn't you know it, it also has a diameter of 2 meters, which means it also has a radius of 1 meter. And that means that it's exactly the same as this circle that we just calculated. So I'm very confident that the area of the shaded circle is going to be 3.14. So if we want the total area of everything, it would be the area of the triangle that has a hole in it and the other triangle, plus the area of the circle that's colored in. So the total area equals the area of the triangle with a hole in it plus the area of the circle that's colored in, which is the same as the circle that was missing, which will be 16.86 meters squared plus 3.14 meters squared. It turns out it makes 20 meters again, 20 meters squared. The reason is, you could imagine somebody grabbed a pair of scissors and they cut a hole right here, but then they moved the object somewhere over here. You know, you didn't lose a total amount of surface area, you just moved it around. So whatever the area of the two triangles were, that's what the area is of the entire thing. So these can get a little bit complicated. Just be sure you understand how to calculate the area of each of the three shapes. So the circle, the rectangle, and the triangle. So the circle is pi r squared. If we review this example here, pi r squared. The rectangle was probably the easiest one, which is just length times width. And then the the triangle is the same as the rectangle, but you divide it by 2. So length times width divided by 2. Hopefully that makes sense. I will see you in the next video.